Now follow me and let me help you understand how this periodic table helps in easy compound formation. Now, first of all, these elements over here are in group 1 element. These group 1 elements found here are called what? Alkaline metals. Alkaline metals react with group 7 elements easily. Group 7 elements are called halogens. So they normally react with group 7 elements easily to form salt easily. As simple as that. Now, group 2 elements are called alkali earth metals. And group 7 are called halogens. Now, let's move on and see something funny about this periodic table. In the periodic table, these vertical aspects are called what? Groups. And the horizontal aspect over here, columns here, are called periods. That is what you're supposed to note. These are called groups, the vertical, and the horizontal ones are called periods. How does this matter in electronic configuration first? Now, anytime the first one is called period 1, so this is period 1, this is period 2, this is period 3, this is period 4. Every element that is found in period 1 tells you that its shells will only be 1. Elements that are found in period 2 tells you that it will have only 2 shells. Elements found in period 3 will tell you automatically that it will have what? 3 shells. Let's prove and see. Let me use lithium over here as an example. So we see. So lithium is what? Atomic number is what? 3. 1, 2, 3. So if I draw 1, 2, 3, how many shells are here? 2. As simple as that. Let me use oxygen. And let's see. Oxygen here. We have oxygen. Oxygen is what? 1, 2, 3, 4, 5, 6, 7, 8. 8. Let's draw and see. So 1, 2, 3, 4, 5, 6, 7, 8. How many shells are here? 1, 2. Simple. Let's go to the third aspect. All these elements here have 3 shells. Let's do another one and see. Let me choose an element like aluminium. Good. 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 8, so it's stable. Let's move to the next one. 11, 12, 13. How many shells are here? 1, 2, 3. Simple. So the periods that they are in will show you the number of energy levels or the shells that the atom will have. As simple as that. That is one of the easiest way you can be able to identify the number of shells an atom will have. And the groups is responsible for the valency. If it's in group 1, it means its valency is what? 1. As simple as that. If it's in group 2, it means its valency is 2. If it's in group 3, its valency is 3. If it's in group 4, its valency is 4. The moment it crosses from 5, 6, 7 over here, ask yourself, how many will be added to 5 to get 8? 3. So it means that the valency of group 5 will be what? 3. How many will be added to 6 to get 8? 2. So it means the valencies of this element over here will be 2. How many will be added to 7 to get 8? 1. So it means the valency over here will become what? 1. As simple as that. This is how you can easily identify the valency and the number of shells an atom will have using the vertical and the horizontal columns of the periodic table. Let's move on to the next aspect, which we call the noble gas. Group 8, we realize that I didn't say anything about it because group 8 over here are called the noble gas. Why are group 8 elements over here called the noble gas? This is because noble gases have an octet electronic structure. When we talk of octet electronic structure, it means that in their form, they already have a stable electronic structure in such a way that their last shells are already 8. So therefore, there is no way they are going to donate or receive. Helium has an atomic number of what? 2. If you draw for helium this way, let's see, 1, 2. The first shell always have to have 2. So it's stable. Neon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. If you draw it, 1, 2. The last shall have to have 8. 1, 2, 3, 4, 5, 6, 7, 8. If you count all, you're having what? 10. It it is stable, so it cannot give or receive. That is why we call them noble gases. These are elements that are not undergoing a chemical reaction because they already have a stable and an octet electronic configuration. So this is why these elements found at the group 8 are called noble gases. Let's see something over here. You realize that normally if you are naming sodium, we call it NaCl, right? KCl. But why is it that calcium, we write CaCl2, and magnesium, write MgCl2? Let's see why. It's so interesting. Now let's see sodium. Sodium is in group 1, right? And it reacts with group 7. So because it's only one over here, it is only one electron, valence electron, or one atom be needed to make it combine automatically. That's why in this NaCl you don't see any substrate over there. Now let's come to calcium chloride. Now calcium over here is in group 2. So all group 2 elements, whenever they are combining with the group 7 elements, because they are in group 2, they are elements, or they are what do you call it, the chlorine aspect, that's the group 7 aspect, will have that group 2 column name attached to it. So these are some of the simple way you can able to they used to name the compounds. So whenever it is in group 2 is combining with this, the group 7 own will have the 2 over there because the element it is combining with is in group 2. Now so you have CaCl, you have MgCl, because Ca is in group 2, Mg is in group 2, but this one is just NaCl and KCl because Na is in group 1 and we don't write the 1, KCl is in group 1, we don't write the 1. As simple as that.